All right, all right, all right. Good evening, good evening, good evening, good evening to all the grade 12 students. How was your English exam? All right. So wonderful, wonderful. Welcome back. Now our last 5 days preparation starts. So we are going to do, as I've mentioned, I'm there with you all students. Nothing to worry. We have done all the chapters one by one, one by one. So these last 5 days are crucial for you all. So remember, in this particular series or whatever we are going to do for all these 5 days are very, very important. So follow all the videos, everything. Any doubt, ask me in the comment section. So today we are going to do, yes, tricks for chemical kinetics numericals. With this tricks, you can completely solve the chapter. Yes, students, yes, follow the complete video because this particular video is going to include, let me write what it includes so that it is easy for you. First, it's going to include you the complete concept map of the chapter. Concept map, why? Because it has formulas, it has units, everything is there in this. Next, you are going to learn the tricks for solving numericals. Okay, the tricks for solving numericals. I'm going to solve the numericals, and along with that I'll be giving you very, very simple tricks for that you can apply. So without log only, I'm going to, without logbook, I'm going to show you that. Next important thing, in this particular video only, you will be getting MCQs. You'll be getting 1 mark questions, you will be getting 2 mark questions, you will be getting 3 mark questions, and you will be getting 5 mark questions also. And along with this, you will be getting 13 years solved PYQs, 13 years solved PYQs. So with this, the complete chapter will be done. Okay, so my request to all the students who are learning chemistry, follow this sequence, students. These 5 days are crucial. You have 10 chapters, so remember to make one timetable. First, follow the handwritten notes which are given. I have sent the handwritten notes. Please study the handwritten notes. After studying the handwritten notes, you are going to follow this last minute series. Okay, last minute series. It will be done. After this is over, then try to go back to your PYQs, solving PYQs. I did PYQs 11 years board papers also I did. So you can follow the PYQs also. And fourth but not the least, you're going to solve the NCRT your question answers. With that, you will be done. You will get 70 out of 70 students. Okay. All right. So let's start the series. Let's not waste time. First of all, for the concept map, as I said, this is the concept map which I've picked up. So this concept map, it is including what actually is a definition of rate law or rate equation, what is the rate expression, what is meant by order of reaction, what is meant by molecularity of a reaction, and what are the units for rate constant for nth order, zero order, first order, and second order. Everything. After that, integrated rate equations table is here, students, and important points. So, what about the molecularity, zero order, first order with the examples? Got it? Now, important. Next important thing before we go, yes, further. In this particular thing, catalyst temperature you have, right? What are the different factors affecting the rate of a reaction? Just like your temperature, concentration, effect of catalyst, pressure in surface area. Again, you have your average rate, instantaneous rate. So this page should come first, but I have given that page first because that's the most important thing. So factors is one, they may ask you for 2 marks. Along with that, what is the average rate, what is the instantaneous rate, that also is done. Okay, so this is just a gist of the. Now let's start with tricks for solving the numericals. I'll tell you in detail. Let us read this question. This is a very quite famous question in your board exams. Let's read. For a chemical reaction, A plus 2B gives me 2C. Concentration of either A or B were changed. Okay, keeping the concentrations of one of the reactants constant, rates were measured. Okay, constant concentration was kept constant and rates were measured as a function of initial concentration. Following results were obtained, so choose the correct option. This is an MCQ question. What do they give me? They have done 3 experiments: experiment 1, experiment 2, and experiment 3. And that concentration of A, concentration of B, and what was the initial rate along with the units. Now, what are they asking me? What actually is the rate? What actually is this? Whether it is zero order, whether it is first order, what actually is this? Because see, based on, they're not asking zero order, first order, but simple thing is they are saying in relation with A, what actually is B? What is the rate? How can I take it? So let us solve this question. As soon as this question is given to you, when they're asking you to choose the correct option, easy step to do, students. Simple. First of all, you have how many experiments conducted? 3 experiments which are conducted, correct? First, you're going to write to the examiner for a chemical reaction. Start writing now because there's a chemical reaction which happened for a chemical reaction. Okay. So for the chemical reaction, what chemical reaction happened here? See, A plus B giving me C, right? So I'm going to take for a chemical reaction, rate is equal to rate constant into concentration of A raised to the power of X and concentration of B raised to the power of Y. Now, why did I take this? See this, only two reactants are there, right? A and B. That's why I have written that those two. Now, here in this case, there are different experiments, there are different values for A and B. Let us compare two. So I'm going to take first experiment, I'm going to take second experiment. Then I'm going to take second and then third experiment. Chalo, let us take. So for experiment 1, so I'm comparing on putting values. I'm putting the values or substituting, putting values for first experiment. What am I going to consider? I'm going to consider the first experiment. What is the first experiment? A concentration was 0.01, B was 0.01. How much was the initial rate? 0.005. So note that. So 0. Instead of rate, I'm writing as 0.005. Okay. How much was A, K into 0.01 X and 0.01y, correct na? See here, you go back. Which is this experiment? This is experiment number 1. Done. Okay. This is experiment number 1. Okay. Now let us take experiment number 2. Next is 0.02, 0.01, 0.00020. So write that 0.20 is equal to K into 0.02 X value. Then comes your Y. How much is 1? Y and Y. This is experiment number 2. Okay. Now what are you going to do? You are going to take or from both the equations, you're going to compare both the equations of whatever is given. Alright. So comparing, what will I write? From equation 1 and 2, or experiment 1 and 2. This is experiment number 1, experiment number 2, equation and equation 2. So you're going to divide both of them. Why we are doing? Because I have to find the value of X and Y. Why we are doing this? Because here in this, they've given me what is the value of A and B, right? That is what I'm finding. So I'm taking both of them. You start dividing this one with this one. So when I divide the first one by the second one, 0.05 is the first one, 0.05. What is the second one? It is 0.020. Then what is A value, students? That is the A value is, see here, 0.01 by 0.02. Take those two values, 0.01 divided by 0.02, whole coefficient is X. One more Y was 0.01 divided by 0.01, whole coefficient is Y. Nothing I did. I divided this one by this one. That's all. So when I divide both of them, 0.005 by 0.2, isn't that 0.25? Normally I when I divide. What is 0.25, students? It is nothing but 1 by 4. Correct. Now when I'm dividing this, I'll be getting 0.5x. What is 0.5x? It is nothing but half. Correct na? Yes. Now 0.01 and 1 is nothing but 1. Correct na? It is only 1. When it gets cancelled, it is only 1. So this is x and this is y. Now completely when I write, because this value, there's no value, can I write 1 by 4 is equal to 1 by 2x? Yes. What is x value, students? X value. So x value is nothing but this 1 and 1 gets cancelled and 2 and 4 goes twice. So x value is 2. Correct na? This is over. This is from experiment number 1 and experiment number 2. Now let us go to the next question. Next part. Now I'm going to divide 2 and 3. 2 and 3. So take that 2 and 3 now. So equation from experiment or equation 2 and equation 3. Correct na? Experiment or 3, whatever it is. How much is equation 2? It is 0.020 divided by 0.060. How much was the x value? It is same. I remember both are same. Okay. Go back and see. Then y value, how much was it, students? It was 0.01 and 0.03. Okay. Is 0.01 and 0.03. What is this? Y value. And again divide this. When you divide this, you will be getting 1 by 3. 2 ones are 2 threes are 6, right? This is how much, students? This is 1 and this is x. This is 0.01 divided by 0.3 is 1 by 3. This is y. This value of 1 x is only 1. So how much do I get? 1 by 3 and 1 by 3. How much is y value, students? The 1, 3 and 3 gets cancelled. So y is equal to 1. And x is equal to 1, y is equal to 1. So before I go to the question, shall we go and substitute in the next one? Go back. You are going to take the x value and y value and substitute in this. Take it. Now how much did I get? I have got r is equal to k value, a value I got it as 2 and b value I got it as 1. So which option is the, students? Go back and check the option. Easy. Yeah, I got it. D is the answer. All. Dividing this by this, dividing this by this. That's all. Easy question. Easy. Let us see the next question. What I get. Next question quickly. One more, one more, one more. This is a very famous question again. See here. In a certain reaction, 10% of the reactant decomposes in 1 hour, 20% decomposes in 2 hours, 30% in 3 hours. Let us make it simpler. Okay. First of all, let us note what is there. What did they say? There is, first of all, decomposition reaction. What is the important thing you should remember? Decomposition is directly related to your time. Directly related to your time. This one you should remember. This is the trick. Rather, this is the most important thing. What did they say? 10% has decomposed in 1 hour. Okay. Then they said 20% decomposes in 2 hours. Then they said 30% decomposes in 3 hours. They say this. Okay, let me check whether it is getting recorded or not, students. Otherwise, it will be a problem for us. Again, yeah, it is getting recorded. Okay. So 3 hours. Now, what did they say? They are asking the unit of rate constant. Which one is this? It is zero order, first order, second order. Let us start with zero order and see. Okay, I'm starting with zero order. Okay, zero order, then first, then second. Okay, zero order. According to zero order, what is the listen, students? Integrated equation A naught minus AT 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 is equal to KT. Ma'am, what is this? What is A naught? This is A naught is initial concentration. Correct, na? What is AT? AT is concentration at time t, means as a reaction passed, concentration at time t. Now you only say if the initial concentration is, what did they say? See here, initial concentration is 10%. Suppose the initial concentration is 10%. It has decomposed, it has decomposed, it has decomposed, and it has formed, it is going to, it's going changing with time. So if initial is 10% means when it decomposition it becomes 90%. Simple, na? 10% it has started. The remaining 90% is going on. That means 100 minus 10 is 10 only, right? Yes, yes, yes. That means what is happening, students? In this case, 100 minus 10 is 100 minus 10 is 90%. Both the ways are same. Okay. That means it is a zero order reaction. Why I'm saying zero order reaction? See here. Here it is exponentially going. So 1 hour, 10% 1 hour, 20% 2 hours, 30% 3 hours. As it is going, it is following this equation, initial concentration and the final concentration. The difference is coming to the same. That's why I'm calling this a zero order reaction only. Before we go to this, what should I calculate? I have to calculate the unit. What is the unit? Now you see, students, zero order, from here only I can take, this is A naught. This is AT, correct, right? So what is this unit? Concentration only, no? So moles per liter. Okay. This is K into time. K into time. So here, did they give me any R? Did they give me any in R? No. They've given me second. So can I write it as time inverse or second inverse? Second inverse. So when I take out, K is equal to mole, liter inverse and second inverse. Mole, liter inverse and second inverse. This is the unit. Simple, simple. So what is the option, students? The correct option for this given is mole, second inverse, mole, liter inverse and second inverse. So option B is the correct one. Mole, liter inverse, second inverse, option B is the correct one. Easy question. Let us do one more question and see. One more question. This is also very famous question, students. Just see. A reaction in which reactant R are converted into product and follows second order kinetics. Okay. If the concentration of R increases by 4 times, what will be the increase in the rate of formation of P? Alright. First of all, they said it is second order kinetics. That means the rate of the reaction, it depends upon, yes, What is this? What is this? This is rate of concentration of rate of the means the particular concentration of reactants. Okay. What is this? This is rate constant. Okay, done. What is this? This is rate of the reaction, second order reaction, correct? Now, what did they say? R is converted to P. This is what they said. R is converted to P and it is following second order kinetics. This is what it says, correct? Okay. Then they said if the concentration of R is increased by 4 times, the concentration of R has increased to 4 times. Let us write that also. Concentration of R has increased to 4 times. That means initial concentration, what was it, students? Initial concentration R is equal to R naught. Now suddenly a new rate has come because the rate has changed to 4 times. No, now initial concentration is this. So new rate, I'm going to write it as R1. R1. R1 is equal to A into how many times the rate has increased. So I'll put a closed bracket. How many times I'm taking this value only, this one only. How many times the rate has increased? It has increased 4 times. 4 of initial rate, 4 of initial rate, correct? And this is second order. This is second order, correct? Yes. All right. Now you only tell me ray R1 is equal to 4. This is 16 times, correct? Now 4 4s are 16. So 16 times of K into R naught. What has happened? 4 times it has increased. 16 times is the rate increase. Because square, no, second order reaction, correct? So how much, what is the answer, students? The answer is 16 times is an answer. Got it? Simple question, just writing the order and calculating. So what should you remember, students, before we go to the next sum? You have to remember one thing. Whenever sum is given, write the rate equation. Right, rate law, rate equation you write. You write the rate equation, it is easy to substitute in the particular thing. In the earlier case also, what did I get? I just took the initial concentration I took, then I went initial concentration, that is R is equal to R naught I took, then I went to the new rate. When I took to the new rate, I applied, I went back and applied it in the rate law and I finished it. Okay, chalo. Let us see the next question. Again, one more famous question, students. In a reaction, 2x gives y. Okay. The concentration of X decreases from 0.5 molar, 50 molar to 0.38 molar. Okay. In 10 minutes. What is the rate of the reaction in mole second inverse during the interval? Okay. First of all, how many pages do I have? One page, I have two page, I have 2 pages only. Okay, let me use this page only here. First of all, rate of a reaction. What did they ask? Rate of the reaction they asked. Rate of the reaction, what is it given, students? It is delta x by delta t. Correct, na? Right. What is delta x? Delta x is equal to x initial minus x final. Correct. Now, what did they say? Delta x here, in this case, they said x decreases from 0.5 to 0.38. So 0.5 was initial, then it has decreased to 0.38. How much is delta x, students? Delta x is, it's coming to 0.12 molar concentration. Na? Okay. Now, next thing, what did they say? They asked me for x has decreased from 0.5 to 0.38 in how many minutes? In 10 minutes. In 10 minutes is what they gave. Correct? Na? So I got delta x value. Can I go and substitute in this formula now? I have to find rate of the reaction, right? Go back. Now, rate of the reaction is equal to delta x by delta t. How much did I get delta x? I got delta x as 0.12. 0.12. Okay, done. How much is delta t? They said, see here. What is the rate of the reaction in moles per second? Where second is what they asked. So go back to that question. How many minutes? 10. How many? In seconds I have to find. So I multiply with 60. The rate when I multiply, I get 0.002. Yes, 0.02002 ms. Can I leave it like this? Can I leave it like this? No, you're not going to leave. You're going to take out the zeros. See how much was the rate, students? I got 0.002, right? Can I further simplify? Yes, I can take this 2. How many decimals are there? 1, 2, 3, 4. 10 raised power of 4. I went towards this side, right? So I'm going to write minus 4. So ms inverse. So the rate of the reaction is, what is the option? Let us go back and see the option. Yes, option is 2 into 10 raised power of minus, how much did I get, student? I got 2 into 10 raised power of minus 4, right? So A is the correct. All right. All right. Let us see one more question. Here we are going to do this question without log table. Let us see. The first order reaction takes place. The first order reaction takes 40 minutes for 30% decomposition. What is a half life of it? Oh, simple. But remember, here this question involves log. We are going to do log or find out log without log table, because they will not give you log table, right? So let us write. First of all, which type of reaction they said? First order reaction. Write the formula, students. Write the formula. First order reaction or rate law. What is it? It is A is equal to 2.303 by T log A naught by A. Correct? This is the form. So what did they say? They said first order reaction takes 40 minutes for 30% decomposition. What will I do? First, I will start with the basic understanding. I'll start, let A be the initial concentration. Let A be the initial concentration. I'll say this A I've taken factors initial. Now they said what after 40 minutes, 30% decomposed it seems. So can I write it as after 40 minutes? After 40 minutes, concentration has concentration reduced. Concentration is 30%. Concentration is 30% decomposed. Concentrate in 40 minutes. After 40 minutes, concentration of 30% of the this one has decomposed. After 40 minutes, concentration has 30% decomposed. Let me write that it is not confusing you all. Concentration has 30% decomposed. This is done. All right, understood. Now from A, so much is reduced means, can I write this as A minus 30A by 100? From A only this part has increased. That part has decomposed. So what is left out? 1 minus 30 by 100, it's nothing but 0.708. Correct, students? Because they said in 40 minutes, 30% has decreased means 100 minus 30 is 70 only. Correct? Alright. So can I substitute, go back and substitute in this formula? Let us see I can substitute or not. So A is equal to 2.303 divided by T log A naught by A. Correct? Now how much is A? How much is T? T value is how much? In 40 minutes they gave, right? So I'm going to substitute that T value. A is equal to 2.303 by 40. Okay. Log A initial concentration of A naught was how much? A. Okay. A divided by A naught after some, sorry, A naught after some time, how much was it? A value was point, a part of it decomposed, 0.708. Okay, now there is a log value which has come. There is one log value which I have to do. What to do with this? Nothing, simple. See, you got this answer, right? See here. K is equal to 2.30340. Now what will they do? They are going to give you a log 7 value. In the exam, they will give you this log 7 value is 0.8451. They'll give you this. So apply this. Log A and A gets cancelled here. Correct? So this is base 10. Always remember it is taken to base 10. So now what is this value? Log the base 10, that is 10 by 7. Correct. I've taken that above, taken the decimal out to 10 by 7. Alright. Now approximate value, when I divide, I got an answer of 0.058. Okay. Divide back. Log A by B. What is log A by B? Log A by B is equal to log A minus log B. Correct na? Log A minus log B. Correct na, students? Now what will you do? Log 10. So log 10 minus log 7. Because log 7 value is here only. So write that. Approximately 0.058. Log 10 is how much? 1. Log 7 is how much? 0.8451. Done. So approximately, now when I multiplied, I got an answer of almost 0.155. So both of them you multiply. Both of them when you multiply, when I multiplied, I got almost 0.00898. So should I leave like that? No, I should not leave that. I should not take that. I value 0.00898. I'll further write it as decimals. 10 8.98 to 10 raised of how many decimals? 3 decimals. This is what I got. 98 or approximately students 98 or 92 rather. So I got the rate constant, but what did they ask me? They asked me to give me half-life period. Come back, come back. Now you're going to calculate T. T half for first order reaction is 0.693 correct na? That is what they gave me. First order half-life. Okay. 0.693. So T half is equal to 0.693 divided by 8.98 into 10 raised to the minus 3. Okay, by minute. Okay, half life na. So when I calculated, I almost got an answer of 77.7 minutes. So this is the answer which I got. Now simple. What did I do? I just made or took the value and applied. It will give you directly. You can write and then apply. Now go back to the option and check which answer. Option A, 77.7 minutes is the answer. Easy, students. Chalo, let us see one more question. Very interesting questions. If you solve this, everything will be done. This is your graph based question. Okay. Now see here. A plot is shown below between concentration and time. There's one plot given. Which of the following given orders is indicated? Whether it is zero order, first order, second order, nothing, students. Basically, you have to remember this page. This page is very important. Why? They will ask you zero order, first order. Note the integrated rate law. Okay, graph and slope. So for zero order negative slope, for first order negative slope, for second order positive slope. Now I'm getting confused between these two. What should I do? Now this is one more graph also which you should study. Zero order, first order and second order. First order, both the cases. Now see here. In zero order, maximum graph will be given with the R naught versus time. This is integrated ln R, ln R by time. Then ln R by time. So remember students, for both it is negative slope only. Negative slope based on this. Y is equal to mx plus c na. Based on that, it is a negative slope. So remember the rate law. Y is equal to mx plus c and check. Go back. Now, which is this? This is ln A versus time. Negative graph. Which one did you get? Which one did you get, students? Negative ln A or ln R versus time. Negative slope and ln R naught. Ln R naught is the intercept. So this is first order reaction. This is for the zero order. This is for the first order. This is also for the first order. Got it, students? Check. This question is very famous question. So please practice this question. I'm going to the next question, students. Yes, easy. Careful. Nothing to get confused. Only thing is gradually understanding the. Okay. In the reaction 2A plus B gives A to B. If the concentration is doubled and that of B is halved, what will happen to the rate of the reaction? Okay. So they have just given me, I think, I'll write the parameters what they gave. First of all, there is one reaction. There is one reaction 2A plus B giving me A to B. Correct? Alright. Yeah. What did they say here? The rate of the reaction is dependent upon rate constant into A raised to power of 2, and then they said A is doubled and B is half. Okay? A is doubled and they said B is halved. Correct? Na? What will happen to the rate of the reaction is that is what they asked. Correct? Let us go back to this and apply the concept in that. What did we write? Rate is equal to, according to us, A, 2 and B. This was initial thing which we have written. Now this is the earlier one. This is R1. Now they said in R2, rate has doubled. A is doubled. How much is B? B has become half. B has become half. Solve it. Easy. So R. So this is 2 square, right? So this becomes K. Becomes 4. This A and this B half. Correct? Now further solving R2. Can I take this? Cancel this. 2 ones are and 2 twos are 4. Comes K. 2 A twice and B once. So what is this rate, students? What is this equal to? Concentration? That's nothing but twice of R1, right? R2 is equal to 2A2. That means which is equal to twice of R1, correct? Twice of R1. Go back. Now before we write, go back. So since, why did I write this to twice of R1? Since R1 is equal to K into A to B, correct? Na? A to B. R1 was initial that thing, right? So when I have seen this, R2 is twice of R1. This complete concept is showing R1, right? A to B1. So R2 is twice of R1. R1 is nothing but A to B. Correct na? So what answer will I write? Go back to the question. Go back to the question. So what is the answer, students? The answer is it increases by 4 times, increases by 2 times, it decreases by 2 times, remains the same. What is it? Just now I got this twice of R1. This doubles it. Twice of R1. R2 is twice of R1 means it decreases twice. It increases by 2 times. Correct na? So increases by 2 times. So seeing the equation. That's done, students. Yeah. Next question. Next question. Next question. In the first order reaction, the reacting substance has a half-life period of 10 minutes. The reacting substance has half-life period of 10 minutes, it seems. What fraction of the substance will be left after an hour the reaction has occurred? The question. What did they say? They said, how many pages do I have? 1 page, 2, and okay, 2 more. So we go to the question. Let us understand the concept. First of all, they said, what is half-life, students? First order reaction, half-life period of 10 minutes. What is half-life? Half-life of a reaction is the time required during which the amount of the reactant which has reacted means it becomes one half of its original. Correct, right? One half of its original. That means amount of reactant left, amount of reactant left unreacted. Amount of reactant left unreacted is nothing but A naught by 2. Correct? That is what? Now, what is A naught? A naught is initial amount. A naught is initial amount. So, amount of reactant left after two half-lives. Two half-lives. What is this? A naught by 2 square. See here, they are given here. First order reaction, substance after half 10 minutes. What fraction of the substance will be left after an hour the reaction has occurred? So, initially, amount of reactant left after two half-lives is equal to A naught by half. Now, amount of reactant left after 3 half-lives equal to A naught by 2. Correct? In general, suppose if I write in general, how can I write this? A naught by 2n. Correct, na students? Yes. Okay. This is understood. Point number 1. This is point number 2. This is point number 3. Now what did they say? They said half-life of first order reaction after 10 minutes. As the 10 minutes as the reaction proceeded. See here, you can only read the question. First order reaction substance has a half-life period of 10 minutes. So what am I writing? Half-life of first order reaction after as 10 minutes passed, as 10 minutes passed, 10 minutes. What will happen, students? That means the number of half-lives in 60 minutes. How much is it? Because they asked in 1 hour, right? So number of half-lives in 60 minutes equal to 60 by 10 is equal to 6. So amount of reactant left after 6 half-lives is equal to A naught divided by 2 raised to the power of 6. Just like this. See here. 2 half-lives means A naught divided by 6, A naught by 2 square. 3 half-lives means A naught by 2 cube. Like that only. A naught 2 raised to the power of 6. So how much is this, students? Nothing but 64 times 64. 64. That means after 6 half-lives, the fraction of the reactant left will be 1 by 64 of the initial concentration. So I go to this questions. I'm again telling you, students, first initially I've written the basic thing. Correct? So shall I complete this? So after 6 half lives, the fraction of reactant left will be 1 by 64th of initial concentration. 1 by 64th of initial concentration. So I just started comparing one after the other. So go back to the question. How much is this? 1 by 60 of initial concentration. Students, all right. So like this, maximum questions, everything I have covered. Now we are not done yet. I'll show you something else. See the 2 marks questions, students. Yes, 2 marks questions. Here in this question, just one question is here, answer is here. What is the rate law? Give reason. You can directly write the answer here. Next. Second question is given here, numerical. The solution part is given here. Further, definitions also, how to write in the exam, definitions are also given here. Okay. Gradually proceeding from there, Arrhenius equation, they're asking you what is intercept, what is in the Arrhenius equation, what does factor E A, that also is given here. Directly write the answer. Further, because this is completely an Arrhenius concept. I'm proceeding. First order reaction 99% is complete. I did one sum, na? Same thing. So question is given. Distinguish between rate expression and rate constant. This was given in 2011. So rate expression definition is here. Rate constant definition also is here. Yeah. From there, gradually, I'm proceeding into calculate the overall order of the reaction. Everything is covered in this video, students. Then they've given you one particular reaction. They're asking you to calculate the fraction of molecules. So how to solve also new question, and the sum is here. All right. Yes, easy. Further, I'm proceeding from here. Questions. Ninth question. This is given. Fine. They're asking you to calculate the initial rate. They're asking you to calculate the reaction rate. The complete solution is here, as explained earlier. Take the sum and note this. Further from there, I have gone into the next concept. Short answers, 3 marks questions. In 3 marks questions, students, see here. What is activation energy question, including a sum? Very important questions are there in this. Please note it. Further, they've given you a graphical based question, calculate the activation energy, curve for catalyzed equation, activation energy in the presence of catalyst question, as well as the solution part is given on this side. Further, one more graphical based questions. Students, remember graphical based questions are very, very important in chemical kinetics. Graphical based question, take this question. Further from this, I've gone to one more question that's based on your calculation of energy of activation. your Arrhenius equation. This also is very important question. Practice it. Then rate constant. One more question. What are the units? What is pseudo first order reaction? Everything is covered in this video. All right. Then from there, gradually, we're going to one more. Okay. So first order reaction is so much calculate T half. So using the first order reaction, you have to apply. Use first order kinetics. That is what they gave. Your T half is equal to 0.693 by this in case they write. You're going to use that. And one more question based on that. Previous year's question, students, as the thumbnail says, from 2010, all the questions are here. Question is here, answers are here. Question is here, answers are here. So please note it. You can directly write, this is according to the board answer key. Board answer key. So you can directly write it like this. Then further, taken one more question. 2013 question this is. Then 2013, 2017. Look, all the questions mixed up, students, all the questions with the answers. So question is on this side and your answer is on this side. Answer is in this. Correct na? So take it. Next, further proceeding. 2009 questions are there. How to write the question, how to write the answer. Everything is mentioned here. So you can directly learn the question and answer. Any doubts, please let me know in the comment section. I'm always there for you, students. Again, 2010 question, the answer along with the unit, how it is solved. Further going into the next concept, 2011 question. See here, this is how the log values will be given in the board exam. So you can directly apply that. Log table is not given, but log values they'll give you, and you can apply it. Also, browse, just Google it, students. World of Chemistry, how to find log without log table. This is one more video. So how to find log without log table is one more video. So you can watch that. It will be very useful for you also. Okay. Yeah. Question 2011, 2013 questions of calculating the half-life period, the second order reaction. The questions, everything is covered in this video, students. Again. Now, further going to 2013. What is the percentage of A to BT? Everything like first order reactions, half-life period, second order reaction, thing is mentioned. Further, 2017, these are compartment questions. No, the compartment questions will be more tougher than the original ones. Please remember. Okay, so don't go for that. Next, further questions. 2009 paper, this is. See the step by step, how they have calculated log value, how they're going step by step. That you can learn for the examination. Any doubts, please ask in comment section. Please ask in comment section. I am ready to answer your doubts. Okay. Next, for the 2015 question paper. Then 2017 paper. Question is given, answer is given. This is according to the board's key, students. Answer key, so half mark and half mark. Learn directly like this. One more graphical based question, which is asked in 2020. Further questions in 2020 again. So the factors affecting rate of the reaction. Rate of the reaction, this is a factor. And further, this is 2022-23 question. This is how it's given, so students. The data, what you write, for the formula, what you write, the bifurcation of marks would be like this. For the substitution and units. So 1.5 mark, you're getting it here only. Next, 2023, and this is 2023-24 sample paper. These are the questions which are given, and both the questions solutions are here. See the answer key also, where their uh, sequence where it is given. That's it. That's it. So this covers complete chemical kinetics. Complete chemical kinetics it requires. So I'll be coming back with organic chemistry again tomorrow. 5 days are left. Maximum I'll be sending conversions. I'll be sending nomenclature. I'll be sending. Don't worry, students. Don't worry. You'll write your particular exam wonderfully. But remember, please follow last minute series, all videos, last minute series. Okay. Join Telegram channel also. Telegram channel, I'm sending all notes. I'm sending MCQs. I'm sending everything I'm sending. Okay. Hello. Please like the video. Please like the video and share the video. Share. Please share. It's the only help I'm asking you. Help. Okay. Take care. Bye. I'll be meeting you all again tomorrow